All right, today we're going to talk about one of the biggest reasons why perfectly good experiments can end up giving you, well, bad results. We're going to pull back the curtain on a really powerful technique that helps you find the true signal in all that data by, essentially, silencing the noise.
So let's be honest for a second. Have you ever run a test, you look at the numbers, and you just get this nagging feeling that something's off? That the results aren't really telling you the whole story? If that sounds familiar, then chances are you've been a victim of hidden variables, these unseen forces that can totally skew your conclusions.
Okay, let's really dive into this. Here's the thing. Every single experiment, I don't care how carefully you've designed it, has this potential flaw that we have to deal with. And that is the presence of uncontrolled factors that can just quietly corrupt our data from the inside out.
In the world of experimental design, these hidden variables have a name. We call them nuisance factors. These are all the things you aren't intentionally studying, but they can still totally influence your outcome. Think about it. In a medical study, it could be the age or gender of the people in the trial. In manufacturing, it might be something like the humidity in the room, or even the specific batch of materials you're using. They're always there, kind of lurking in the background.
And this is where it gets really serious. Nuisance factors create what we call statistical noise. It's all that messy static that can completely drown out the actual signal you're trying to hear. And when that noise is louder than the signal, well, that's when you start drawing false conclusions. And that can lead to some really costly, really misguided decisions down the line.
So, how do we fight back against this invisible enemy? We can't always just get rid of these factors, but you know what? We can outsmart them. The solution is this really elegant and powerful technique from the Design of Experiments toolkit. It's called strategic blocking.
So what exactly is blocking? Well, it's not about ignoring these nuisance factors. Nope, it's about confronting them strategically. The whole idea is actually brilliant in its simplicity. First, you identify the nuisance factor. Then, instead of just letting it randomly mess up your results, you systematically spread its influence evenly across all of your experimental runs. By making sure everything is balanced, you completely neutralize its effect.
Now, theory is great and all, but to really get this, we need to make it concrete. So let's walk through a simple case study to see exactly how blocking can transform an experiment from something vulnerable to something truly robust.
All right, so take a look at this. This is your classic before scenario. It's a standard experiment with 3 factors and 8 trials. Those pluses and minuses, they just represent the high and low settings for each factor. Simple. Now, on the surface, this looks perfectly fine, right? But here's the hidden danger. Imagine our nuisance factor is the gender of the person running the trial. If, just by pure chance, all the high settings for, say, factor B are run by men, we have no way of knowing if the result we see is because of factor B or because of the gender. Their effects are hopelessly tangled up.
So how do we fix this mess? The blocking procedure is a very deliberate 2-step process. First, we figure out our blocks. Since our nuisance factor is gender, male and female, we'll create 2 blocks. Easy enough. Step 2, and listen, this is the really clever part. We have to distribute our 8 trials into these 2 blocks. The goal isn't just to have 4 in each. The goal is to make sure the combinations of our factors are perfectly balanced across those blocks, which we can do using a standard scheme.
And voila, here is the result. This is the after picture. We've still got our 8 trials and our 3 factors, but now we've added that all-important 4th column for our block, gender. Look closely. We have 4 male trials and 4 female trials. But more importantly, check out factor A. Within the male block, factor A has 2 minus settings and 2 plus settings. And it's the exact same for the female block. This perfect balance is repeated for factors B and C. By designing it this way, any systematic effect from gender just gets mathematically canceled out. It can no longer be mistaken for an effect of our main factors. Pretty clever, right?
So, we've walked through the mechanics, but let's zoom out to the big picture for a second. Why does going to this extra effort matter so much? What's the real strategic payoff here? Well, the benefits are crystal clear, and they are incredibly valuable. First, you get much cleaner, more accurate data because you've basically isolated and removed the noise. That in turn allows you to draw conclusions that are way more reliable and trustworthy. And that leads to the ultimate goal, right? To make smarter, evidence-based decisions that move your project or your business forward with real confidence. And that brings us to the final, critical question I want to leave you with. Now that you understand the power of strategic blocking, take a second and think about your own work.
What unseen nuisance factors might be influencing your results right now? What should you be blocking in your next experiment? That's not just a statistical question, that's a strategic one.